lecture number 5, AP Chemistry, and we are going to attempt structured questions related to mass spectra of elements. First of all, carbon 14 is a radioactive isotope used in carbon dating. The mass spectrum of a carbon sample is shown below with two peaks at m by z 12 and mass to charge ratio is 14. So you can see that mass to charge ratio at carbon 12 is 98.93% abundance, while the carbon 14 has the abundance of only 1.07. Explain the significance of the relative heights of peak in the mass spectrum. So first of all, what does the peak at carbon 12 shows? That peak at mass to charge ratio 12 shows that there is more carbon 12 in the sample. So what does that show? The peak at m by z 12 shows that carbon 12 has more amount in sample. Calculate the relative atomic mass of carbon in the sample. How can we do that? The formula that we have already seen, that I'm going to multiply 12 if we want to find the uh, relative atomic mass. I have to multiply it with the percentage, that is 98.83. I'm going to put it in the bracket, then 14 times 1.07 divided by 100, and the answer comes out to be 12.02. Then carbon 14 is although present in very small amount in nature compared to carbon 12. Explain why the low abundance of carbon 14 does not prevent it from being used for dating ancient aircrafts. So, if we want to use it for ancient, like dating ancient aircraft, then its small quantity can be even detected during the radioactivity. So, I'm going to write that its radioactivity that allows it to be detected in very small amount. So in this question they ask us that the mass spectrum of copper shows two peaks at mass to charge ratio is 63 and mass to charge is 65 with relative abundance of 69.15% and 30.85% respectively. So first of all they ask us that what is basically the relative atomic mass. So relative atomic mass is the average of the mass of isotope relative to 1 by 12 of the mass of carbon 12. Use the given data to calculate the relative atomic mass of copper. So we are going to use the same formula, that the mass multiplied by its abundance 69.15 plus 65 multiplied by its relative abundance, that is 30.85, divided by 100, and the answer comes out to be 63.62. Now we have to draw the spectrum, mass spectrum. We have two charge ratios. One is 63 and the other one is 65, and we can write 64 here, 66 here. So 63 has the abundance of 69.15. We can show it's 69.15. It's this place is for relative abundance, and this place is for mass to charge ratio, and 65 it is going to be 30.85. We can put it up till here. We can mark here as 30.85. So in this question they have given us the mass to charge ratio of neon, that is 20, 21 and 22. What does the presence of three peaks in the mass spectrum indicates about neon? So it indicates that neon has naturally three isotopes. Calculate the relative atomic mass of neon. So again we have to just multiply 20 with its percentage abundance, and then 21 times 0.27 plus 22 times 9.25 divided by 100, and the answer comes out to be 20.18. So a scientist claims that a sample of neon is enriched in Ne22. Explain how the mass spectrum of such a sample would differ from that of natural neon. So if we are going to draw the mass spectrum, then we are going to see that relative abundance of Ne22 increased significantly. So it would show us that the relative abundance of Ne22 that increase significantly. So in this question they are saying a sample of metallic element M is analyzed by mass spectrometry. The resulting mass spectrum shows two peaks. The one is 63 and the other one is 65 mass. Identify which isotope of element has more neutron. So definitely as we know that M65 that has greater mass, so it has more neutrons. Calculate the average atomic mass of element M based on the spectrum data. So how can we do that? We just need to multiply 63 times 69.1, its abundance, plus 65 times 30.9, its abundance, divided by 100, and the answer comes out to be 63.62. 618. And the element is copper. Copper has the atomic mass of 63.55. Then D part says compare the number of protons, neutrons, and electrons in M63 and M65. So definitely, as they are isotope, so both have same number of proton and electron, but M65 would have two more neutrons. Explain why the average atomic mass of element may vary significantly between samples from different resources. There could be the reason like you know the average atomic mass of element may vary slightly between samples from different sources due to either due to the environmental processes, that could be the reason, or we can say either due to geological processes. They differ because of these processes. A student suggests that the mass spectrum might be from a mixture of two different elements. Explain whether the spectrum supports this claim or not. So basically, there is no evidence of additional element or unusual mass differences. So we can write that there is no evidence of additional elements or unusual mass differences. So now he's saying the sample is enriched in M65 to 90% abundance. Predict how the new mass spectrum would differ from the original and also calculate its average atomic mass. So we are going to see that the peak at M65 become much taller, and because of that what will happen, the new average would become like 0.10, or we can uh, do like 63 times. If its abundance is 90%, then definitely the abundance of 63 would be 10%, plus 65 times its abundance is 90%, and now I'm dividing it with 100. So the answer comes out to be 64.8. Determine whether the coin is likely to be genuine when its abundance 63 is 60% and 65 is 40%. So you can see that now we have different abundance, and what can we write like that deviates significantly from the natural ratio. You can see that now the percentage now the percentage abundance differ from the natural ratio. So what will happen because of that? It would suggest that the copper might be sourced from, it suggests that copper might be secured from from non-natural source. That's why its percentage abundance actually varies. So in this question they are saying that there is a transition metal which is J. One sample is made entirely of isotope G50 and other is made up of G52. Both are used to synthesize G2O3, a common oxide of metal J. They are saying calculate the molar mass of G2O3 and determine the difference. So when we have J50, then what will happen? It is going to have the molar mass of 2 times 50 plus 3 times 16, and it is going to become 148, that is gram per mole, and the other one is going to be 2 times 52 plus 3 times 16, and it comes out to be 152 gram per mole. So difference will be 4 gram per mole. And in the analytical chemistry, this difference could be significant. This difference would be significant. In analytical chemistry. Why? Because that would affect the calculation, because it would vary the calculation related to percentage yield, or either that could be limiting reagents. So these calculation would vary if there is difference in the molar mass. So now we have a question. A student analyzed a metallic sample believed to contain only one element Q. The resulting mass spectrum is shown below. Based on the spectrum, how many isotopes of the elements are present? So we have 1, 2, 3, 4, 5. So there are 5 peaks, that means there are 5 isotopes. Explain how the student knows that the sample only contain one element. As you can see that these are closed peaks having the difference of 2 or 2 and 1 and 1. So because the spectrum shows closely spaced peaks, the spectrum shows closely spaced peaks. That means which have, you can say, which have consistent 1 to 2 AMU spacing. That is why we can suggest that it is basically it contains only one element. Now for the next question, use the spectral data to calculate the average atomic mass of Q. So just we are going to do the same process, that we are going to multiply like mass with its percentage, that is 26 times 64 plus 66 times 17.5 plus 67 times 7.5 plus 68 times 5.5 and divide everything by 100, and the answer comes out to be 63.93 AMU. The 62 AMU, the 62 AMU isotope relative abundance affect the calculated average atomic mass by it caused the average atomic mass to be lower. Okay, because the average atomic mass before it was if the 62 would be having the as the highest percentage abundance. Explain how this affect calculated the average atomic mass. So 62 is the lowest one. If its percentage abundance would be the greatest one, so it caused the average atomic mass to be lowered. Okay, so the average atomic mass becomes lowered as the one which is 62 would be have the highest peak. So a sample of Q analyzed and has a mass of 1.91. So we have to calculate its mole. So the formula of mole is equal to mass, that is 1.91 divided by molar mass, which we have calculated 63.93, and the answer comes out to be 0.0299. Number of atoms, if you want to calculate the number of atoms, then it is going to be mole times molar mass, mole times Avogadro's number, that is 6.02 times 10 raised to power 23, and mole is 0.0299 times 6.02 times 10 raised to power 23. The answer comes out to be 1.80 times 10 raised to power 22. Now we want to find Q forms a Q plus 2 ions and reacts with chlorine gas. So we have to write the balanced chemical equation. The equation is going to be Q plus Cl2, and we know Q is having plus 2 charge, chlorine is from group 7 having negative charge, so the formula becomes QCl2. And determine the empirical formula. So empirical formula is also QCl2, and if they want to find the type of bonding, then it must need to be ionic bonding, as Q is a metal from group 2 as it is having plus 2 charge. So this is all about.